All right, beautiful people. Our essential question is, why do we move the decimal point when multiplying decimals? So yesterday we talked about multiplying decimals where one of the numbers was a decimal and the other one was a whole number. But today we're going to do example 2, which is both of the numbers are going to have decimals in them. Okay, so we're going to examine what the difference is and talk about why we move the decimal point. So our first example is 4 and 8 tenths times 7 and 2 tenths. I want to do the same thing that I did yesterday. I want to estimate so that I know if my answer is close enough or if I've missed something up. So 4 and 8 tenths is really close to 5. And then 7 and 2 tenths is really close to 7. So 5 times 7 is my estimate, which is 35. So I want my answer to be close to 35. So if it's like 34 or 36 or something in between, it will be really, really close. I just don't want a really big number or a really small number. Okay, so the first thing I'm going to do is set it up. 4 and 8 tenths times 7 and 2 tenths. But I remember, like yesterday, that I don't know how to multiply just decimals. Like, it doesn't make sense to me. So I do know how to multiply whole numbers. So I'm going to make 48 a whole number. So I move the decimal one spot. Okay, and now I've got 48 as a whole number. But 7 and 2 tenths still has a decimal in it, and I want both of them to be whole numbers. So I move this a second spot. So here's one more spot, which makes 72. And now I have two whole numbers. I have 48 times 72, which is going to make it so much easier for me to multiply. But I need to remember that I didn't just move that decimal one spot. I moved it one spot for 4.8, and I moved it one spot for 7.2. So in total, I moved the decimal 2 spots. So when I multiply and I'm done, I need to move it back 2 spots. Okay, because I have to account for not just the 4 and 8 tenths, but the 7 and 2 tenths as well. Okay, so now I'm going to multiply. 2 times 8 is 16, carry the 1. 2 times 4 is 8, plus 1 is 9. Placeholder 0. And then I cross off the 2, and I'm going to erase that 1 up here. 7 times 8 is 56, carry the 5. 7 times 4 is 28, plus 5 is 33. Okay. All right, and then I'm going to add those together. 6 plus 0 is 6. 9 plus 6 is 15. Carry the 1. 3 plus 1 is 4, and 3 plus nothing is 3. So my answer is 3,456. That is way off from my estimate of 35. But wait, I forgot to move the decimal back in, so I need to move that decimal back in. It says I need to move it 2 spots from the right. So I start on the right, and I go 1, 2 spots in. And this answer is 34 and 56 hundredths. And if you look at my estimate of 35, these two numbers are really close together. So I know that my answer is a reasonable answer because it's close enough to my estimate. Okay, so again, this is why it's important to estimate so that we know whether our answer is realistic or not. And it's also really nice to move the decimal out because if I didn't move it out, I wouldn't have known where to put it in this first example, in this first solution or the second solution. So I wouldn't have known where to put it in the total. So it's really important that we do both of those. So our key idea today is very similar to the key idea from yesterday. The key idea is make decimal terms whole numbers every time you have a decimal in multiplication. For multiplication. I know I left out an L. Hold on. Multiplication. By moving the decimals. So we moved it for 4.8 and we moved it for 7.2. After you multiply, move the decimals back in the total number of places moved. So something that I remember from last quarter is that we figured out that the word total means to add. So that's why I took the 1 spot from 4 and 8 tenths and the 1 spot from 7 and 2 tenths and added them together to get 2 spots because total means to add. And 1 plus 1 equals 2. So this became 34 and 56 hundredths. If I didn't add them together, then I would have a completely different answer. I would have had 345 and 6 tenths, which would be way off from my estimate. So again, super important that we move the decimal back the right amount of pieces.